All right, so today what we're going to talk about is transversal proofs. So if you are already able to identify all the stuff that's here in this vocab box, right? If you're able to pick out all the corresponding angles, same side interior, same side, sorry about that, same side exterior angle, alternate interior, alternate exterior. If you're able to identify that, you're going to be in pretty good shape for today. Because all we're going to be doing is we're going to be talking about proofs and how we're going to use that information as our reasons in these proofs. So if you aren't familiar with it, I'm going to go over very quickly kind of what this looks like, just as a refresher. If after this refresher you're still not understanding it, we have other videos on our YouTube page that you can go check out that might be able to help explain it a little bit more. So real quick, just talking through them, we've got corresponding angles. I always think of them as two angles that are in the same spot, but in a different group of four. So for instance, angle 1 here is on the top left. So on the top left of this other group is going to be angle 5. So angle 1 and angle 5 are corresponding to each other. For our next one, right, we have same side interior angles. So we're looking for two things that are in between the S and the T. And if they're on the same side in this case, it means they're either going to both be on the bottom or both be on the top. Depending on how it looks, it could be left or right. But in this case, I'm looking at something like angle 3 and angle 8. For alternate interior angles, I'm going to keep those other interior angles highlighted, but it's going to look like something like 3 and 5. So as opposed to the other one, those are going to be on opposite sides of each other, not same side. And then last but not least, we have alternate exterior angles. So that's going to look like 1 and 7. They're outside of lines S and T, and they're on alternate sides of each other. And if we know that these two lines are going to be parallel to each other, denoted by those little arrows, if we have just one angle measure, like we do here for number 2, we know that that angle is 75. We actually know all the rest of the angles that are listed on this. So we know that 1 and 2 are linear, so we know that this is 105 degrees. We know 2 and 4 are vertical, so that should be 75 degrees. 1 and 3 are vertical, so that should be 105 degrees. And then to get these bottom 4, it's like we just copy and paste down here. So 105, 75, 75, 105. So again, that's a little refresher for things that we've kind of talked about in the past. If you want to go over, this is good if you're looking for reviewing over the vocab terms. I'm not going to go over them right now. But if you have questions, you can always ask your math teacher. So when are we going to use this stuff? So when we're looking at these proofs, all right, and it's clear that we have two lines cut by a transversal, all right, we're most likely going to find either that the lines are parallel and we're going to prove it using one of those angle relationships, or we're going to do the opposite, and we'll talk about that here in a little bit. So for both of these examples, right, I'm trying to find where P is parallel to Q, and that is a given statement. And I'll stop bouncing between the two. I'll just do the one on the left. Well, P is parallel to Q, that's given. So if we know that, we know for sure that angle 3 is going to be congruent to angle 6. And the reason that we know that is we know that if two parallel lines are cut by a transversal, alternate exterior angles are going to be congruent. So our reason is alternate exterior angle theorem. I'm just going to stop it right there. Alternate exterior angles. All right. Same with the next one. All right. We know that PQ, or P is parallel to Q. That's a given statement. It's saying why are 3 and 8 supplementary? So you could put down same side exterior angles, kind of like it's noted up here. I know that at least in my class, we didn't talk about that as much. So we can still use the relationship between these angles to help us figure out that information. So for instance, if I know that these two are parallel, well, I know that angle 3 is going to be congruent to angle 7 because they're corresponding angles. I know that 7 and 8 are supplementary. So angle 7 and angle 8 are sup because they're a linear pair. And then last but not least, if I know that 3 is congruent to 7, and 7 and 8 are supplementary, I can substitute that in. Angle 3 and angle 8 are supplementary due to the substitution property. So a lot of what we can do is use these, use the relationships that we know between these angles as our reasoning over here to help us draw our final conclusion and get this statement that we're trying to prove. And we can also do the reverse. All right, so listed here are all the converse theories. So let's think for a second. We've been talking a lot about conditional statements and their converse previously in this unit. So all we're doing is we're doing the opposite. So our normal corresponding angles theorem is if we have two lines that are parallel, then the corresponding angles are congruent. So if we have the converse, remember we're switching our hypothesis and our conclusion. So we get if two lines are cut by a transversal so that the corresponding angles are congruent. So if angles are congruent, then we can prove that those lines are going to be parallel to each other. So it's just the converse of all the relationships that we've talked about before. Alternate interior angles. If those alternate interior angles are congruent, the lines are parallel. If the alternate exterior angles are congruent, the lines are parallel. The only one that's slightly different is the consecutive interior, or I think we call them same side interior angles a lot. It's just saying that if the two angles are supplementary to each other, if they add up to 180, then those lines are parallel. Looking at these examples, I'm not going to go through every single one of them, but all it's saying is that given the information that we have, we're trying to determine which lines are parallel, and we're going to use our converse statements from above to justify it. So really all it's saying is identify the relationships between the angles to be able to determine whether or not those lines are parallel. So looking at this first one, it says that angle 2 is congruent to angle 4. Well, the first thing is I want to look to see, well, actually first I want to figure out the converse actually. So if those two are congruent, well, those are both in the top right of their group of 4. So if they're in the same spot, well, I know that those are going to be corresponding angles. So they do have a converse, which is good because that means that two of the lines are going to be parallel. And one way I like to help determine which lines they are is I like to highlight the two lines that those angles touch. And then in this case, right, C and D would have to be the parallel lines. We're not comparing A to anything else. So C and D are the ones that we're looking at that would be parallel. So by starting off by figuring out which converse we're going to use based on the angle relationship, then we could go back and prove that those lines are going to be parallel to each other. Let's try one more, and then we'll start looking at the section below. So we've got 5 and 10. If you notice, let's start with our converse first. Well, based on what I see, if 5 and 10 are congruent to each other, what's their relationship? Well, they're alternate interior angles. So since they're alternate interior angles, we know that two of those lines are going to be parallel to each other. So I'm going to highlight the two that touch angle 10 and the two that touch angle 5. And from the looks of it, it looks like A and B are going to be the ones that are parallel to each other. All right. So again, we're using the relationships that we know between these angles and using their converse theorems to figure out which lines are going to be parallel. So again, I'm only going to try one or two of these just so you can see it. If you want good practice, going through and working through all these is really going to help out. But even when it's something crazy like this, right? Kind of going through the exact same way that I did before. Let's look at angle 9 and 22. And if I'm looking at 9 and 22, I'm kind of ignoring all these other numbers right now, right? So if I look at 9 and 22, based on what I see, right? I might even highlight the lines in this one first. I see this line here and this line here. So based on those yellow lines, I see that those two are alternate exterior angles. So that's the converse that I'm going to use because I know that they're congruent, which means that Q is going to be parallel to R. All right. Same thing with the next one. We've got 8 and 13. add up to 180 degrees. So I'm going to highlight my 2 lines, or I guess 3 lines that I'm looking at. All right. Based on those lines, I see that these two are going to be same side interior angles. And same side interior angles are supplementary when the lines are parallel. So which 2 lines are parallel? Well, it's going to be P parallel to Q. All right. So you can go through, you can kind of look and figure all of these out. It'd be a great way to look at it. But the way that I suggest is taking a look, find where those angles are at, highlight the lines, talk about what relationship you see between the angles, and that'll help determine whether the lines are parallel, and in this case, which lines are going to be parallel. All right. And then we're going to walk through just 2 more of these proofs just to see an example of what this looks like. So first one that we're looking at is proof number 3. So we're going to look to see if we can prove that J is parallel to K given the information that we have. Sorry about that. Sorry if there was a little hiccup there. I had something I had to take care of. So we were looking at proof number 3 here. So we were saying that given our statement that angle 4 and angle 5 are supplementary, we want to prove that J and K are going to be parallel to each other. So first things first, I'm just going to take a look right here, kind of highlight them so I can see. It says 4 and 5 are supplementary. Remember, our first statement is always our given statement. So it's telling us that angle 4 plus angle 5 equals 180. So based off the information that we have above, we can draw this conclusion. Why? Well, that's just the definition of supplementary. All right, it's kind of explaining more of what that means. I'm going to abbreviate it when I write it. And then last but not least, it says that J is parallel to K. And why is that? Well, if we know that 4 and 5 are supplementary, given the location that they're at, right, we're going to be looking at the fact that these are, not alternate, same side or consecutive interior angles. And that's going to be our reason to support why those are parallel to each other. All right. In fact, it should be the converse, right? Because we're ending up proving those parallel lines in the end. So same side interior angle converse. All right. And now we'll look at the last one. So it says that 1 and 2 form a linear pair. So that's our first statement here. So that's a given. And it says that 1 and 2 are supplementary. Well, that would just be the definition of a linear pair. Right? If we have a linear pair, that they're both adjacent and supplementary to each other. Our next line says that 1 and 4 are supplementary to each other. So why do we know that? Well, that's a given statement. All right. If I know that 1 and 2 are supplementary and 1 and 4 are supplementary, I know that due to substitution, that 2 should be congruent to 4. So that would be my substitution. And then last but not least, I'm going to take a look. I said that 2 and 4 were congruent to each other. So A and B have to be parallel lines because, well, 2 and 4, what's the relationship? Corresponding. And since we went backwards to find that the lines were parallel, we didn't have that information before, it's going to be the converse. All right. So a lot of the stuff that we did with our proofs for transversals is just using the names of these angle relationships that we already knew as our reasons, as our justifications for things such as parallel lines or why things are supplementary and why things are congruent.